Welcome everybody to IndEx online webinar number 9, EX industry myths, room for improvement and solutions. Really do appreciate all of you attending. Just wanted to show everybody our faces and give you an idea that we really do appreciate your time. Okay, I'm going to turn off the webcam now so that you guys can concentrate directly on the presentation. Okay, so my name is Michael Merrington. I'm the General Manager of IndEx. Now, what is the need for hazardous areas? Well, we've experienced disasters. So an example would be Piper Alpha on the bottom and Macondo, Deepwater Horizon. Now, for Piper Alpha, the key findings were, why do events like these happen? Well, poor quality management systems or poor quality systems of communication, occupational health, safety, and environment, poor management of change, poor permit to work systems, poor quality of maintenance, of integrity, inspections, and design of electrical and instrumentation systems, hazardous areas, cables, basically human factors. So if we ask you the question, what is the intent of all these different ISO, International Standards Organization, ISO 9001, quality management systems, ISO 14001, 18001, 45001. What is their purpose? So this is multiple choice, don't be shy. We're at about 43% voting. I'd like to get up to 70% and close. Give another 10 seconds. Okay, closed. Only 57% shared voted, so I believe people are scared probably because they're unsure of what these systems are. Basically, they are quality management systems for different fields, and they're just standardized all the different quality management systems for these different fields. 9001 is quality management systems, 14001 is environmental, 18001 is for occupational health and safety. Then there are other ones. They are means to standardize quality management systems because the biggest factors is always the humans. So the industry has been going through a wrong response lately. So with these disasters happening, Philadelphia Energy Solutions explosion in May of 2019, 1,300 people without work. Port Neches chemical refinery explosion, sending 20,000 people back to their homes when there's asbestos all over their yards, lawns. The response in US industries is that the cost of insurance is driving US chemical makers and refiners to lower coverage. They are lowering their number of staff on, they are lowering the number of inspections and lowering their maintenance. So succumbing to the cost of insurance and cutting back on coverage, well, it could lead to high risk outcomes. It will lead to high risk outcomes. It will lead to explosions, full stop. How many times do we need to repeat these issues within industry until people learn? So what's a good approach? Well, having controls in place. What do we have? Well, if we look at the Swiss cheese model, basically you don't want your holes to line up, the faults to line up at each control step. So you can have engineering controls. So say you have an event or a hazard, you can have engineering controls, safer design, safety instrument systems, Isolation of hazardous energy, lockout, tagout, which is a much more effective means of control. Less effective is administrative controls, secure lab procedures, making people have to wear PPE, doing a JHA or job safety, job hazard analysis, management of change, and safe work practices. Behavioral or PPE level is a very weak way of stopping events from happening. So wearing your PPE, stop work authority, using the correct tools. So to visualize it in the easier way is, well, what's the most effective in the hierarchy of control is isolation or elimination. You remove the hazard. It's inherent. It won't be there. Substitution, you replace the hazard. Engineering controls isolate people from the hazard, passive and active. Now, unfortunately, within industry, whether it be hazardous areas or oil and gas, mining, a lot of safety personnel like to apply administrative controls, trying to change the way people work. That's what do they say? Trying to herd cats. It's a very difficult prospect. And then making people wear PPE. Okay, wearing a glove is not going to stop an explosion. Probably should be going into the engineering substitution or elimination level. So, the need for the EX industry. Well, back in the 1800s, when digging for coal, they would ignite clouds of gas with a stick with flames on the end. This obviously caused explosions. Then somebody invented the Davy lamp, where it had a mesh on it where it would not cause ignition of primarily methane for underground. Now, throughout the early 1800s, they had signaling systems, 12 volt or 24 volt signaling systems, where they would use their shovel to complete the path between positive and negative to activate the bell, let them know they're coming up or they're coming down. Well, this was found to be the cause of quite a few explosions in underground coal mining. 439 miners killed at one incident, another 81 miners killed in 1901. So this was the original, well, the need for the EX industry. You know, the increased EX is basically industrial equipment to a higher level of quality. Now, when we look at rooms for improvement, take a look on the left here. This terminal was too tight, so it broke the screwdriver. So actually the termination was incorrect. A tool within the industry exists for how you're actually supposed to tighten terminals, a torque screwdriver. That's a good, well, change management, implementing of a good quality management system would be use the correct tools. So if the vendor, manufacturer, EPC, or end user provided their workers with the correct tools, things like this would be lessened. Well, what else do we see in the industry? We see that manufacturers ship devices with plugs, blanking elements, glands, without any EX markings on them. Is this acceptable? Well, to -0 general requirements, even for very small pieces of equipment, in the case of very extremely small EX equipment and extremely small EX components, where there is no practical space for marking. I would digress and say there is space here. It shall be, if there's no practical space for marking, a marking intended to be linked to the EX equipment or to the EX component is permitted. This marking shall identify, as applicable, and shall appear on a label provided with the EEXE equipment or the component for affixing adjacent to the EEXE. So what it should say is, on the actual EEXE label of this instrument, it should make mention of this plug, not back on its data sheet. This causes a lot of delays in industry. So a manufacturer, perhaps having a cheaper plug, causes issues, yeah, because the amount of man hours for the end user and the EPC increases significantly. Now, even for EXD, where cable glands are an integral part of the enclosure or specified for the enclosure, those shall be tested as part of the enclosure concerned. So if it's part of it, it doesn't necessarily have to be marked itself, okay? This plug doesn't necessarily have to be marked, but they have to make reference, yeah, to it on the marking of the equipment. They didn't do it in this instance. The easiest way would be just mark the plug. Now, here's a question for you guys. If we were talking about plugs without markings, how about shipping plugs? So plastic plugs. Will they cause issues in the future? So just so everybody knows, all voting is anonymous. Even I will not know who voted for what. We're at 70%. I'd love to get this up to 100%. Give another 10 seconds. Okay. I would like to say that 23% of you are causing further issues in the industry. To expect everybody to know that a shipping plug is only a shipping plug is making an assumption. And there's a certain saying about assumptions, which I will not repeat, but devices are received and the average EPC assumes that everything is good on it and good to go. So on one side of the fence, in the manufacturer, there's assumptions. And then at the designers, there's assumptions. Installers, there's assumptions. Do you see where I'm going? Yeah, the holes are aligning. We've already shown plenty of devices without glands installed, without plugs installed, or shipping plugs. Because remember, a shipping plug on an EXD device, that's a very dangerous prospect. So I would hope that people would learn from the shipping plug. Saving yourself $1 perhaps isn't the greatest. It could make your vendor or your manufacturer reputation take a big hit. Okay. Well, when we look at this piece of equipment, I think everybody would think that this is an old piece of equipment. It is not. This is a brand new piece of equipment. So what do we have here? Significant room for improvement needed within the vendor. Yeah. Well, what do we see here with other manufacturers? Receiving of instruments with painted earthing points. Within electrical, instrumentation, control, well, all industries, earthing bonding is extremely important. It helps reduce the sources of ignition. Once again, unmarked plugs, or perhaps just a little HF mark on it. But is that HF mark on the EX data plate? No, it was not. rooms for improvement. Cable glands. Everybody likes to say they're easy. Why is it that there is always significant issues within our industry? Because people make the assumptions that they are easy. Once again, the vendor, is there perhaps a lack of leadership? Perhaps they're managers, but maybe they do not have the competency to understand what they're looking at, or other human factors. By the cable tags being right up against the cable glands, there is now no way to back the cable gland off for detailed inspection, which is a requirement. What's the significance of the armoring? If it is not properly terminated, there is the chance for ignition. Also, if there's a cut in the cable, the whole point is that the fault, any electrical current will hopefully travel through that armor into the gland, through the device, and go to the equipotential bonding, go to the path of least resistance, not through a human or through a piece of equipment, and hopefully not cause an ignition. So what can you do? Be a leader, not a manager. Apply quality management systems. It's not hard. Show people pictures of good installations. Then these gentlemen and ladies did exactly as they were told, and they learned why it was better. When they see something good, they repeat something good. When all they see is something bad or poor quality or lesser quality or average, they'll just keep repeating that. So there's ways to do things better. Just show them pictures. Yeah. So let's ask you a question after you saw this for just a moment. How many potential sources of ignition are there that cause 95% of all ignitions? So 95% of all ignitions in any industry, gas, dust, vapor, non-hazardous areas. %65 voted. I'd like to get a lot more on this one. Okay. I'd like to say that this is, guys, there's 13 or more sources of ignition. Yeah. So the 8% that said 15, yeah, you're pretty close. And the ones that said 13 or more, well, let's take a look. Guys, there's over 13 potential sources of ignition. Yeah. Not just, everybody always likes to say that this is the flame side of the triangle. No. Or heat. No, it's ignition sources, not just flames, not just fires, cigarettes, cutting, welding, hot surfaces, heated processes, hot process vessels, or space heating equipment, but also, which has to do with, hazardous area industry, mechanical machinery, electrical and instrumentation equipment, friction heating or sparks, impact sparks, sparks from electrical and instrument equipment, stray currents from electrical and instrument equipment, electrostatic discharge sparks, static electricity, lightning strikes, electromagnetic radiation. Now, Also, vehicles. Yeah, we're going to show evidence of all of this. So, ignition sources, mechanical machinery. Well, 2008, Georgia sugar refinery explosion. 14 dead, 36 fatalities. Sugar dust. They figured that a conveyor was built up of dust and the bearings overheated and caused a flame. Yeah, caused an ignition of sugar dust. So why is there ATEX and IECEx rated mechanical machinery? Because it is a potential source of ignition. Let's show you sugar dust. Remember, a flame is at a lower temperature than static electricity. Okay? Well, for electrical instrumentation and control. Why is it important? Well, take a look at this incident. Look at all those sparks going on. Is that a big spark? I'd say that's a big spark. Now, what do we have? Well, within our industry, we have EXDE circuit breakers. Yeah. The E is the terminals, the D is inside. Now, let me point out that this must go into an EXE enclosure, such as this one on the right. Okay? Electrical and instrumentation equipment. Sparks from that equipment and stray currents. So, source of ignition, friction heat, spark and hot embers. Well, in food, wood, any industry where there's dust can cause explosions. So what happened? Well, dust going through HVAC systems, yeah, they can heat up as they hit into each other or hit other pieces of metal, or maybe the process, there's hot embers. So what can be done? Well, there are spark diffusers, flame arresters, like the ones you see here. Also, there are EX conveyors. As we pointed out, the sugar industry, the bearings, when they failed, caused ignition. Well, earthing, bonding, grounding, and shielding systems. Well, this is a very large, well-known industry that has obviously a lot of risks. So your lightning, if you don't have lightning protection systems on your facility, well, say your flare, your cracker, those are certainly high. The chance of lightning strikes hitting them are quite significant. Wherever we have offloading of product, whether it be a chemical or gas or liquid, we have to equalize the potential between them to remove all static electricity. Then we have our protective earthing, grounding systems, our instrumentation clean earth. We also have our functional earthing and intrinsically safe earthing. All of the instrument, clean earth, and intrinsically safe earthing has to be isolated from each other and from the regular earthing systems. Why? Because if you have circulating currents, you can have a potential source of ignition. Now, random question here for you guys. Sorry about the misspelling. Is IP68 rated for IP66? Can I use an IP68 rated only device for an area that is rated IP66? %, voted. Okay. 30% of you. No, you cannot. IP68 is not rated for 66. Please watch IndEx Online webinar 4 and 5. Within industry, we've gone through this many a times. 6 is only rated for 1 to 6. The 7 and 8 for water, for immersion, is only rated for 8 is only rated for 7 and 8, and 9 is only rated for 9. Okay. Back to earthing, bonding, and shielding. Why is it highly important? Well, on the left there, you see a battery room explosion. Batteries under charge produce hydrogen through their vents. Static electricity ignites that hydrogen very well. So, and why did this explosion happen? Static sparks, explosion in Kansas. So, explosion in a flammable solvent storage tank. They had a level gauge that was a metallic level gauge. Let's just say if your earthing, bonding, and shielding systems are not correct, static electricity will bite. So once again, intrinsically safe systems, we really have to consider that those instruments are being used for critical things: process measurement, control, perhaps shutdown. So your plant and personnel integrity systems, safety instrument systems, and fire and gas. Now, what about vehicles? Has anybody ever seen BP Texas City? That video is not working, but basically, BP Texas City, I believe 14 or 16 people killed. What was the source of ignition? A truck. They had an uncontrolled release of chemicals, and then which let off a vapor, which was then sucked into potentially the air intake and was ignited that way, or by the hot muffler. Now, people don't think that's a big issue, but are you going to tell people where they can drive on site and that that's your hazardous area? And okay, the hazardous area is in just that one little area? Do you control which way the wind blows? Or would you possibly consider that the possible ignition sources on a vehicle, whether it be electric or internal combustion, well, the motor needs to be EXD or E, the battery, the remote control switch has to be EX, the battery has to be EX, the battery connector and socket have to be EX, the lighting and control systems have to be EX. The electrical installation is a potential ignition source. It has to be EX. Mechanical devices such as brakes and hydraulic fluid components is another potential source of ignition. It has to be EEX. Hey, electrostatic discharge or charge. Static electricity. So your wheels need to be conductive. Your seat needs to be conductive. Your safe, where they keep the batteries, needs to be conductive. There needs to be grounding against electrostatic charge. Sparks made by metallic components. Plating with bronze, brass, or stainless steel. Temperature control. Yeah, hot processes. And the motor or exhaust. So why do we have to consider all these things? Well, we already have examples within industry. You can say on your facility, that won't happen to us. Pretty interesting thing to say. Now, there are EEX vehicles and forklifts. On the Shell Prelude, they use EEX forklifts. They're a combination of EXD, flameproof, increased safety, EXE, intrinsically safe, EXI, and a couple other different protection techniques. So they do exist. Where did they arise, the need arise out of? Well, incidents like this. How many times do we need to kill people? Now, how about clothing? Now, within the IEC and ATEX world in Australia, there are defined standards for anti-static workwear that is also fire rated. Why? Because static electricity will cause ignition. And if you doubt it, well, I showed you the battery room. The minimum ignition energy for hydrogen is extremely low. Yeah. So when we look at the static, you can see that all it takes is 1 millijoule to generate static electricity, while the igniting current for hydrogen is significantly below that. Okay. So I'd like to thank everybody. Let me put out just a few more polls to you guys, get your insight. This one was more to raise awareness about all the different types of static electricity and potential sources of ignition. So if we ask the question, let's see what people's thoughts and opinions are. Is clothing a potential source of ignition? You know, there's a standard that exists for it, which we showed you. (63% voted. The 3% that said clothing cannot cause ignition. Okay. Guess you won't change your mind. But considering that there's a standard that defines the risk, perhaps go read that, I would suggest. Now, let's get an opinion on this one. What plays the biggest risk in any industry? If you read any of the CSB, so the Safety Board, OSHA in America, or the report on Piper Alpha, or on Macondo, or on the Montara oil disaster, or the Georgian sugar refinery, or that crude oil carrier that just ignited yesterday in Indonesia. There's going to be one factor that is the biggest risk? Okay, guys, the biggest risk is always humans. They install it wrong. They design it wrong. They don't do enough maintenance, or they don't do enough inspections, or don't do it well enough, or don't do it at all. Why does this happen? Because humans like to say, that'll never happen to us. I've never seen it happen. I've never seen it happen. So if a tree falls in the woods and you do not see it or hear it, it did not fall. Same within our industry. Now, will not having quality management systems or verification of competency or emphasis on right first time cause potential sources of ignition? So let's just say you have highly skilled personnel. Do you just trust them to always do the right thing? Or do you have systems and standards in place? Okay. So for the 8% that said no, every mechanical, electrical device you use throughout your life has been designed to a standard, has quality standards applied to it. Have you ever flown on a plane? Have you ever driven a vehicle? People have died for these standards to then be applied. So my question to you is, how many must die until you apply? Here's one for manufacturers or EPCs or vendors. Will poor instructions or overly complicated instructions cause issues for EPCs and end users? And I would like to add, could it possibly raise potential sources of ignition? So if we go back to the Swiss cheese model, so anybody that answered no before, luckily no, there was no no's on this one. Every single time you don't consider having any of these controls in place, you're just allowing the risk to potentially happen, a higher percentage chance that it will happen. Okay. Now, here's one for you guys on IP ratings. Now, when we talk about arcs, sparks, static electricity, does an IP protection play any part in this? Dust, water. Is IP54 sufficient for EX equipment? Water conducts electricity. Dust conducts electricity. Water and dust can cause electrical sparks and arcs. So for the 9% that said yes, I'd like to ask you, is it sufficient full stop, or must you consider environmental factors? That's directly in the standards. Also, the standards are only a minimum. So the bottom three answers were correct. Please consider that water gets into everything. Just because a manufacturer does not hear about their piece of equipment failing does not mean it hasn't. Yeah. Trees always fall in the woods. Water always gets in equipment. Just because you don't hear about it doesn't mean it has not happened. Now, when we talk about how to mitigate all these risks, well, there's one set of devices that play a major role in the industry. Instrumentation. So what roles do they play? Okay, 70%, let's share that. Guys, without instrumentation, none of any of these new facilities would exist. They give us measurement of the process, control of the process, shutdown, emergency shutdown, venting to the flare. If you can't measure what's going through the pipe, how do you know when it's overpressured or underpressured or what the temperature is? So how would you know the pressure, the temperature, the flow, any of these things without instrumentation? You wouldn't. Instrumentation is highly critical to plant facility safety and integrity and personnel integrity and safety. Fire and gas systems. Safety instrument systems. Yeah. Okay. So we'll open it up to questions now. If anybody has any questions, please ask. So just go back on and show examples. So terminals, tighten too much, poor quality management system. Guy was just using his hands, or maybe a screwdriver, or electric battery drill, who knows? Okay, so we have a question. Can you explain continuous super inspections concept? So continuous supervision is a concept that some facilities implement because it's a cheaper method of doing inspections. What they mean is that they are saying that their workforce is competent, as in they are all trained in all the EX protection techniques, which they are working on. And as they do their campaign maintenance and working with the equipment, that there is no need, they feel, to do further inspections through continuous supervision, that they see their facility every single day and that there is no need to do periodic inspection campaigns. So it's more of a things will be okay mentality. But the problem is the human factors. People, it looks the same to me as it was the other day or 6 months ago when I saw it. Can you remember 6 months ago what it exactly looked like? I doubt anybody can unless you've got photographic memory. Okay, next one. One second. In 60079-17, after initial inspection, how to decide the periodic inspection? Well, the standard, as we explained, standards are applied so that there's standardization in the industry to reduce confusion, is a 3-year periodic inspection campaign. So basically you do 33% of your assets every year for 3 years with varying degrees of visual, close, and detailed inspections. As you find faults, you really should find out the reason why and be proactive and perhaps predictive. Does all EX equipment need to be inspected every 3 years? Some actually needs to be inspected every 6 months. If you're using portable equipment, there's a need for every 6 months. If you're working with EXD, I believe it's every year. Intrinsically safe is one that apparently you only need to do every two years, I believe. But once again, it depends on the facility. The end user shall make the call, but perhaps they should utilize experts in owner's engineering. Somebody made the comment, continuous supervision is a poor method, as the more you see, the less you observe. Correct. The more information you have in front of you, usually people zone out and miss the finer details. So you observe less faults. Been on many sites where these have been left in and even signed off by EX personnel. So shipping plugs, once again, I have the experience and many other people have the experience where the shipping plugs are left in. So the EX protection technique on EXP, D, and others with the shipping plugs left in is a very significant risk of potential ignition. Existing sites and rezoning and change out of equipment. So existing sites can be rezoned, but you take into account what is existing as to not cause issues for the end user. Obviously, you can rezone everything and you could potentially cause your company, the EPC, to make a lot of money and cost a lot of money for the end user. I would not be one to suggest that, and I'm not be one to do that. That is unscrupulous. There's not always the need. You can do risk assessments. Now, when people say hot pipe work is not covered under IEC, but it is covered under ATEX. Correct. Manufacturer's challenge. What percentage of technician does read the installation manual before installation? Well, as a former technician, I'll give you input. Practically none, especially when it comes to heat trace. Practically none. Because does the EPC print out all the instructions for everybody to use? Practically never. Or perhaps they don't give you everything. If you have partial information, that can be just as dangerous as no information. Somebody said, when I said practically none, somebody said so true. Yeah, I've worked on that person on a few facilities. That is true. What common human factors can occur when handling EXE battery boxes? Well, people dropping them, people hitting them, people scratching them, moving the battery box around, scratching it. You know, it has a outer surface, probably GRP, which won't hold a static charge. Also on the batteries, perhaps they over tighten the bolt onto the post so they can damage that, or maybe it's too loose. The more you have humans having to install or modify something or telling them to use a torque wrench, how many actual facilities give their employees a torque screwdriver or a torque wrench? It's a simple fix. Have one person go around doing all the torquing with that one torque wrench, and he's trained at that. Simple fix, but how many people are managers, and how many are actually leaders? On one vessel, which I seem to have shown, over 6,000 damaged batteries on lights during construction. Wow. So what does that tell you about the installation technicians? Does it mean they don't know what they're doing? Or perhaps they don't know what they're doing because they weren't given the correct information. And also, perhaps they weren't given the correct training. And perhaps the quality management system wasn't in place. And perhaps, you see what I'm getting at? All the holes are aligning because people like to say, that's not my responsibility. I'm not part of that department. It'll be okay. I've never seen a bad battery problem. Well, yeah, when the vessel leaves Korea or some other location where it was built, do you see what happens out in the middle of the ocean if you're not out in the middle of the ocean? If a tree falls in the woods and you don't see it, it doesn't fall in your mind. But on many sites, yeah. Now here's one for everybody. Who has actually read the instructions of how to use their multimeter? I'm going to make a quick assessment, probably 99%. People do not read instructions. Who has read the instructions for their car, their truck? Probably nobody, unless the thing has broken down and you have no money and you want to fix it yourself. Okay, I think I'll give it another 30 seconds if there's no more questions. One thing I will tell you is on the Montara FPSO, there's one interesting design choice that they made that goes against everybody's logic. A lot of people think that intrinsically safe systems are a glorious way of doing instrumentation. If any of you follow us on LinkedIn, you'll see that many people do not know how to do instrumentation because of how complex it is. When you inspect an instrument, let's go to the drawing. So when you inspect the instrument, you're supposed to inspect the system, the field mounted instrument, the enclosure, its barrier, its cabling, its simple apparatus, simple devices. Now, do you have the DSD, the detailed system document, with all the certificates and all the data sheets and all the information of that intrinsically safe system? If no, then you have not been inspecting as per the standard. Remember, the standard is a minimum. In case of maintenance of EEHA equipment, is it necessary to redo the EEHA certification? When you're doing maintenance or inspections, you're not going to redo any certification. So there is confusion in certain regions in the world. People think that an inspection is recertification or certification. It is not. You're just doing an inspection. You're doing a snapshot in time to verify that things were done correctly. Now, the only time that you would recertify a piece of equipment is if it was damaged and you would send it to an IECEx repair facility or the manufacturer, or if the manufacturer was out of business, you could potentially recertify it if it met the standards, but deviated from the original certificate. Okay, I'd like to thank everybody for attending, and really do appreciate your time, and all of us from IndEx. Thank you. Once again, my name is Michael Merrington. Welcome to IndEx Online, webinar number 9. Hopefully see you next week. Thank you very much.